and welcome to Chainlink Tech Talks. Today, we'll be talking about how bZx automates their smart contracts with Chainlink Keepers. This talk is being recorded on Wednesday, September 29th. I'm Chirag, and joining me today are Anush from Chainlink Labs, as well as Roman and Drypto from the bZx teams. Thank you all for being here. Let me now give you a quick rundown of the agenda. We'll kick off today's session by having Anush talk about what Chainlink Keepers are and the impetus behind why we created them. We'll then hear from Roman, who'll introduce bZx, talk about their needs for automation, and walk us through the liquidation use case. And following that, Drypto will talk about bZx limit order implementations. We'll then close out with a live Q&A where you get to ask your questions. So now I'd like to welcome Anush. Anush, please take it away.
Thanks, Chirag. So smart contracts have emerged as a highly secure form of digital agreement. They establish a source of cryptographic truth that all parties involved can rely on without having to place trust in brands or centralized black box software. However, they do have a limitation. Smart contracts are not fully automated and therefore cannot execute their own functions based on predefined conditions or time. They must be triggered from some external source. It could be a user pushing a button on some user interface, a DevOps team that is responsible for operational tasks, or perhaps a centralized bot that is running some simple script and taking actions as needed. In the end, an externally owned account must initiate the on-chain actions and must do so reliably, which can become costly, cumbersome, sometimes difficult to maintain, risky, and oftentimes centralized. In order to sleep soundly at night, projects have to invest heavily in infrastructure that meets the strict properties required for reliable automation, or they avoid features that require time or event-based execution altogether. So we built Chainlink Keepers to provide reliable smart contract automation, as well as some off-chain computation. Witnessing these problems firsthand ourselves, and having worked with so many projects in understanding their pain points, we recognize how much of a need there is for projects to outsource their automation with a high degree of confidence that their work is going to get done. The Chainlink core node software has already been built with the properties of reliable automation in mind, and we've been doing this for years now. So our goal then was to expand our technology to cover trust minimized automation and off-chain computation to the entire blockchain ecosystem at large, providing small and large projects alike a simple and easy way to offload their automation needs. Now with Chainlink Keepers, smart contracts can be automated based on time, say every day at 4 p.m. Eastern, external conditions, perhaps the completion of some sports event or some new weather data has come in, a computation where a loan has been determined to be under collateralized, or any combination of the three to take actions on your particular set of work. So let's briefly discuss the 5 of the most important benefits of Chainlink Keepers. These represent some of the aspects that we took into consideration when building Keepers product in general. Much of it is driven based on the base tenets of the product development philosophy we have at Chainlink Labs. First is that Chainlink Keepers are decentralized. The Keeper network is a decentralized network of Chainlink nodes that securely automate the smart contracts, mitigating risk of manual interventions or scripts running on centralized servers. Keepers are run by the same node operators that secure billions of dollars in DeFi today. The second aspect is that we wanted to make sure that Chainlink Keepers keeps the costs low and stable. Our Keeper networks are economically incentivized to perform all registered upkeeps, and they do not compete with one another, resulting in lower and more predictable costs for your transactions. They use a unique turn-taking algorithm that ensures no one keeper has a monopoly on any registered upkeep. And each of them takes responsibility for a different set of jobs during each term. And all of this is enforced on-chain. The third aspect we wanted to cover is off-chain computation. You can offload your compute-intensive tasks, such as checking for conditions, which can cost anywhere between 100,000 gas or a couple of million gas. And you can send that over to the Keeper network and trust it to take care of these actions for you. Then pass back data on-chain for execution, allowing you to do a lot of off-chain compute and then performing just a subset of tasks that are required on-chain. This requires nothing more than the code, your own Solidity code deployed on-chain, making the Keeper network a powerful off-chain compute infrastructure, running your audited code off-chain without incurring gas costs, then broadcasting transactions on-chain when conditions are met. The fourth thing I wanted to cover is making sure that Chainlink Keepers are easy to integrate with. Making your existing contract Keeper compatible can be done in a matter of minutes. Creating an entirely new Keeper compatible contract can be done in a matter of hours. Our documentation provides a step-by-step guide on how to get set up and is continuously improving based on user and community feedback. And finally, high uptime is a critical property of reliable automation infrastructure. Not only are Chainlink Keepers run by world-class DevOps teams, ones with verifiable historical reliability, even during extreme market volatility and network congestion, but the network itself has inherent failover built in as a property of the turn-taking algorithm, ensuring your work gets done even if some of the keepers are down. The network continues to operate effectively, even if there are partial outages or there's congestion within the blockchain network itself. There are three main actors in the network. The first part is the client contracts. These are the Keeper-compatible smart contracts that need external entities to service their maintenance tasks. This could be a proxy wrapper of an already existing deployed contract, which can make it easier for future upgrades. It could be an updated version of an existing contract to make it Keeper compatible, or a new contract altogether built from scratch to be Keeper compatible. The second part is are the keepers on the network. These are the Chainlink nodes that execute registered upkeeps. Each keeper node continuously performs off-chain condition checks at every single block, then broadcasts a transaction to the blockchain as soon as conditions are met. They manage gas price selection as well as gas bumping as required to ensure your transactions are confirmed in a timely manner. And the third piece is the keeper registry, which brings together the client contracts and the keepers and enforces the rules of the network to ensure all parties play fair and payment is provided for work that is performed. There are two simple parts to integrating Chainlink Keepers. First is to write a smart contract that is compatible by implementing the check upkeep and the perform upkeep functions. The check upkeep portion of your code is run as a neat call off-chain at every single block. And provided your check upkeep returns true, it means it is time to take action on-chain. When this happens, you can also pass back information from your check upkeep from the off-chain compute to your transactions broadcasted on-chain, your perform upkeep function. This allows you a drastic amount of flexibility to define exactly what you need on your check upkeep, then perform only the subset of work that is required in your perform upkeep by passing information back and forth. To dig further into this, please visit docs.chain.link and read about it for yourself, and feel free to get started right away. The second step is to register your smart contract for upkeep with the Chainlink Keeper network. To do this, you can visit keepers.chain.link and see currently registered upkeeps and register your own. And with that, I'll turn it over to Roman to talk about bZx, how they're using Keepers today, and some of their exciting future plans.
Hi, everybody. My name is Roman. I've been working at bZx for almost 2 years now. I do mostly a Solidity smart contract development. bZx is a margin trading, lending, and borrowing platform. Very recently, we transitioned to a fully decentralized DAO. Our DAO is one of the top 10 largest DAO in the industry, with a value over 150 million. We plan to do a major rebrand very soon. Coinciding with the rebrand, we are partnering with Rarible for NFT launch collection, featuring 18 brand new limited edition NFTs and the launch of the merch store. We are partnering with known DeFi projects such as Sushi, B Protocol, Tidal Finance, EPNS, and many more. Currently, we are deployed on BSC, Polygon, and obviously Ethereum. Soon to come are Optimism, Arbitrum, and Avalanche. bZx DAO has a permissionless liquidation system. Anybody can participate in the liquidation and earn profit. The more people are participating in the liquidation, the more protected is bZx DAO from extreme market volatility. Before Chainlink Keepers, there were multiple entities running liquidation scripts, and nobody was guaranteeing execution. In case of market crash, participants have no obligation to liquidate orders. With the Chainlink Keeper, we have a fully decentralized job that ensures timely execution of unhealthy positions. Let's discuss in detail the architecture of the liquidation system and Chainlink Keeper integration. As you can see on the diagram, Chainlink Keeper network constantly calls check upkeep to see if there is new work. If there is a new task, the perform upkeep is called. Flash loan magic is happening after that in the liquidation contract. For people who don't know what flash loan is, it's an under collateralized flash loan that has to be returned in the same block. And after that, flash loan is made to liquidate current position in the loan amount. This loan amount is sent to the bZx protocol to cover the loss. bZx protocol then returns collateral. Liquidator is swapping this collateral back to the loan, and the amount is returned to the flash loan. This process is called repeatedly until the system is healthy again. Up to 2-3 liquidations right now can happen in one perform upkeep. And in the future, we plan on whitelisting only Chainlink Keeper smart contracts to trigger liquidation, and profits will be automatically returned back to the protocol. We are working closely with the Chainlink Labs team on enhancements. All contracts are open source, and you can find them easy on the GitHub. I'm always eager to help any integration coming bZx way. The links will be available in the description when it gets posted. Thank you. And I'm introducing Drypto, who is going to discuss the limit order.
All right, so I will be discussing the use case 2, which is limit and market stop orders for bZx. And I will be going over the problems, solutions, and how it's used within the bZx ecosystem. So let's start off with what are limit and market stop orders. Limit orders are orders that stay on the order book. They are filled by other traders and are what make up the order book you see on, like, let's say, a centralized exchange. Market stop orders are orders that are conditional, and those conditions dictate when it's executed. The most common condition is price has to cross a certain point. If these conditions are met, the market order will be executed. The benefits of these order types cannot be overstated. The ability to manage risk through the usage of market stop orders is a lacking piece within the current Fulcrum trading experience, which is bZx's trading margin trading platform. Market stop orders fix the issue of the lack of risk management, as you're able to set the price you want your position to close out at a loss in advance. So if you have a position open and you say at a certain price, I want this position to be exited out because I don't feel that I want to keep the position open for further loss, you can. And it's also great for limit orders, and limit orders are also very beneficial for this because you can put a take profit using limit orders, and you can also put limit orders for entering positions at a price you feel is a good price to enter at. But obviously, if the current price is not there, you just set a limit order and it'll be filled in the future. So the challenges of limit orders in DeFi are that on EVM-based chains, there is no native limit or market stop order based exchange that has taken over or that has major adoption. And smart contracts can't automate their own execution, as we all know. That's the whole need of Chainlink Keepers here. So this has resulted in a solution needing to be done for the support of limit orders and market stop orders for bZx. So next slide, which has brought us to the creation of limit orders that are market orders with constraints, which is we created a system that uses market orders that can act like limit orders and market stop orders that act like they are in a centralized exchange. So the term that I'm using for this is quasi limit orders, because the limit orders themselves are market orders, but their conditions are set in a way where the execution received for the order has to be better than or equal to the execution price desired. Now, implementing this requires a consistent source of contract upkeep. So this is where we used Chainlink Keepers. Chainlink Keepers provides the integral piece to any advanced contracts, but especially for bZx in our use cases, because we need a consistent upkeep of the order book, and obviously for liquidations, as Roman mentioned. So it's going to be integrated fairly deeply into our protocol in many different avenues. These checks occur every block. Executions will happen every few blocks. This will allow for a reliable source to ensure orders that are executed in a timely manner, and that the order book state stays up to date. So now let's go over the limit order architecture with Chainlink Keepers. So this is the architecture diagram for an execution on the Chainlink Keeper end. The diagram shown here is a process for execution, as I've said. So the first step is a check upkeep. This sends a transaction or call. Sorry, not a transaction, but just a off-chain call to iterate through all the orders on the order book state to check them. So to run check orders, which is a call within the order book contract itself that goes through certain checks to ensure order validity. And if any of the orders are open for execution, it will return that data as a payload, and Chainlink Keepers will call perform upkeep. Perform upkeep will call the execute order function in the order book, and will either open it and then run some internal checks to double check that the order is actually valid for execution. Then it will either open or close the position, open or close their position depending on the order type, and it will pay an incentive out. This incentive will stay within the order book upkeep contract and is given to the Chainlink Keeper job. It is converted to link and given, so the system is self-sustaining. So let's now go over the overview of the order process. The first step of the order process is a trader places a trade on the order book. So this trader is someone who this trader is anyone who wants an order executed. So they will obviously just place on the order book. The next step of this is Chainlink Keepers will continuously monitor the order book to check for potential executable orders. So it'll run through the whole order book state as we saw in the previous slide. And at every single order, if one of them is up for execution, the keeper will submit a transaction that will execute the order. So it'll submit it to the execute order function. And then the fourth step is if the transaction submitted by the keeper executes the order, if the keeper successfully executes the order, the keeper is rewarded. So this will be paid out in link, as that's what Chainlink Keeper jobs use. So this is a detailed analysis of the order process. We will start off on the left side, which will be order execution. The execute order function passes parameters on which order to execute. And these parameters are based on the trader's address and the order ID for the trader. The next step is there are price checks done to ensure the order is valid. And then it will call open position if the order is a limit open order. And if it is not a limit open order, it will do close position, which is for close limit orders and market stop. If the order execution is successful, an incentive is paid out to the caller. On the right side, this is the order execution validity checks. The first call, this is usually run off chain, as there's numerous amount of checks. So the first call is to check order. Then it branches off into 3 different paths based on the order type. So for open limit order, we'll start there. It does a balance check. This balance check is based on the order data and the balance of the trader. So it ensures that the balance of the trader is greater than the minimum amount of tokens needed to actually execute the order based on the order data. If that is not true, so if they have less tokens than needed, it will return false immediately. So the caller knows that the order cannot be executed. If it does return true, it will do an execution price check, which ensures that the current DEX price is better than or equal to what the trader wants their limit order executed at. This also does take into account price impact and fees charged for trades. So there is no, so it's actually what is received. The the other 2 order types, close limit order and market stop order, they follow the same check paths. So the first check path is a loan ID check. This ensures that the loan ID specified in the order data, which is your actual position ID on the bZx contracts, is actually an open order, or sorry, an open trade. And if it's not, it'll return false. And also if they have rights to the trade. So there's a internal record keeping of which positions are delegated to which traders. So if they don't have the rights to execute and close out a certain position, then obviously it'll return false to the caller. But if both those checks pass, the next check is a position size check. This uses the position size on the trade on the trade and the order data. So if they're trying to close out a position that, or sorry, if the close order itself is larger than the position, it'll return false. But if it's not, if it's less than or equal to the position size, it'll continue and do an execution price check. The close limit order check is the same as the open limit order check. So there's nothing new on that. But the market stop order is different in the sense that it will check to see if the Chainlink reference rate has crossed the execution price, the desired like stop price. And then it'll run a second check, which will ensure that the DEX price is within 0.5% of the Chainlink reference rate. And this is to ensure that there is no sort of flash loan attacks being done, where you can front run the orders and then basically sandwich attack a market stop order. This limits the power of that and the potency of it. So if those checks are returned true, then on the execution price check for both types orders, it will return true to the caller, and the caller is made aware that the order can be executed. So this is a connect with bZx slide, bZx and Chainlink. Those are the websites to go to either place, and the Discord links to join. bZx does have a developer Discord channel where you can ask any questions, and a developer will likely be around to answer. I know I monitor very closely along with Roman and the other developers.
Thank you, Drypto, as well as Roman and Anush. It was really great hearing from all of our speakers, including the bZx team, as well as from Chainlink Labs, Anush, and we're looking forward to the future plans. Folks, we're going to go live to a Q&A now. Please type your questions in the Zoom chat about Chainlink Keepers or any questions you may have for the bZx or Chainlink Labs teams. Also, there's a short survey in the chat. Please take a moment to fill it out and help us improve our tech talks. Thank you. All right. Hey, everyone. Welcome to the live Q&A portion of this tech talk. We are already seeing many of you type in your questions, so I'm going to request my fellow panelists and speakers to turn their cameras on. I see Anush there. Anush. All right. And we also have Roman. All right, there's Roman. Hey, Roman. All right, and then we have Drypto as well. Okay, folks, so I'm going to kick off with the first question from Colin. And Colin says, how does not competing for jobs keep the costs down for Chainlink Keepers?
Right, that makes sense. So it's perhaps not particularly intuitive, as in most cases, like in the real world, competition helps reduce the cost for consumers. There are a couple of different models by which you can make sure payment is made for keepers doing their work. And working through some of that, we really identified that it is important that in order to avoid scenarios where work does not get done and we need to make sure it gets done reliably, it's important that these keepers are paid for whatever gas costs they spend in order to complete that work. So what can happen if, say, you were allowing anybody to take the actions, enterprising individuals, enterprising organizations can then monitor what's happening in the mempool and see that actions are being taken, as well as choose to use very high gas prices when trying to execute your work. So if you're going to be paying them back for the gas that's being used, then I could just select I could throw in a transaction for 1,000 Gwei. And we need to make sure there are protections in place for that, which the Keeper Registry does. But on top of this, if you have, say, multiple ones competing, we might try to outcompete one another to the point where you end up paying more because you're covering the gas costs plus some additional amount to make sure the keepers are getting paid. So when we create a system in which they have to cooperate rather than directly compete, we can ensure that one keeper is within the particular turn responsible for your upkeep and has an opportunity to complete it before another one attempts to make that same upkeep happen. So that helps keep the cost down for our consumers.
Awesome. Thanks for that, Anush. Colin, I hope that was helpful. Thank you for that question. I have the next question queued up here, which is from Mike. And I think it's a great question. This is kind of a broader question around automation. How do you see automation evolving as the blockchain ecosystem grows and becomes more sophisticated? And then where do you see Chainlink Keepers play a role in that?
I think I can answer that. I see a use case with the Chainlink Keeper and the DAOs in general. DAOs for now are entities that has to have somebody trigger transactions for them. And Chainlink Keeper can actually automate their own tasks, even maybe pay itself for running the transactions, some maintenance jobs. Maybe they can, make a complex scheduling of transactions, paying salaries, and running tasks for them out. I think so. I think Chainlink Keeper has a use case here.
Right. I think Roman, you and I have talked about this a little bit, but we're at the infancy of both blockchain and automation infrastructure within blockchain, right? And a lot of projects we've spoken with have told us about like their strategies they've taken in the past, the pain points they've experienced and such. And oftentimes it kind of just becomes simpler to not deal with automation. You can create an entire set of smart contracts and applications relying on smart contracts that don't have a need for automation or reduce the need for automation. So as outsourcing this to a reliable network becomes more and more available to more of the ecosystem, I think we'll see something new and interesting evolve over time. I don't know if we can necessarily predict how it's going to be used, but now that it's no longer as much of a barrier for entry, anyone, a small group or a large project, can relatively easily outsource this work and ensure that it's done reliably. So I see this as an opportunity for the entire ecosystem, and I'm very much looking forward to seeing what people end up doing with it.
Makes sense. Yeah, thank you both, Anush and Roman, for that insight. We have a next question from Cryptic, and the question is, it's related to the limit orders that Drypto was talking about earlier. So the limit order book, how does that change landscape for centralized exchanges versus decentralized exchanges? Probably Drypto, do you want to take that one?
Yeah, sure. So the introduction of a limit order book and also market stop orders into decentralized exchanges is very huge. Currently, only centralized exchanges really have that outlook on EVM-based chains, as was stated in the presentation. And closing this gap allows for a better experience on decentralized exchanges that is currently not available. So obviously, there are limit orders that are implemented, but having the ability to have limit orders with margin trading is currently not being done. And having this on bZx's end will allow us to bridge that gap between centralized exchanges and decentralized exchanges and make it more competitive overall.
Sounds good, Drypto. Thanks for that. All right. Folks, yeah, just a reminder, feel free to keep adding your questions here. Okay, Edwin says, what are some ways you may use Chainlink Keepers in addition to the liquidation and limit orders that you folks discussed today?
Maybe I can start off with this one, and you guys can think through what you're thinking as well. But it's not just the users that are already using Chainlink Keepers today. There's just a large variety of options available to anybody because of the flexibility of the system and the fact that you can just write it into your own Solidity code. You can pretty much do anything. So we have some users doing automated vault harvesting. One awesome one is ensuring that all of the addresses that you need to maintain are fully topped up. So you can make sure that if it drops below X amount of ETH, you fund it with Y amount of ETH. And that way you're not woken up at night when, say, some node in your network or some address of yours is dropping below some limit. It can be used as an emergency situation or as like a regular funding operation. We have some users distributing rewards using keepers. So when a particular event occurs, it's time to close a period and then distribute the rewards. Starting and stopping games, rounds for various use cases. We have some that are rebasing their tokens at every single day or every couple of days. Rebalancing your vault based off of information that's already on the network. And other ones that are unique as updating the characteristics of an NFT based on certain conditions that are met. So I think like as we continue seeing more and more users adopt automation infrastructure like Chainlink Keepers, we're gonna it's an open system to the point where anyone can do anything with your Solidity code. So based on that, I think we're gonna see some very interesting over the next year or so.
Sounds great. Yeah, definitely very exciting times, Anush. And then Roman, probably from your side, has bZx thought of any other potential opportunities for automation apart from the ones you folks were discussing today with liquidation and limit orders?
We have some internal jobs that we might want to automate. Specifically, we have a rollover. So every 28 days, we have to roll over the loan so that we pay interest to the lenders. Yeah, so we can use that to do. Yeah, and maybe there are some other maintenance tasks in the future that we might want to automate.
Cool, awesome. And Roman, while you're still on with the mic, so there's a question related to your rebranding. So there's a question from Lexi which says, all these upcoming features sound exciting. Do you guys have an estimated date for your rebranding and rolling them out?
Yeah, as with every other DeFi projects, we get a lot of questions like when is the major thing happening again? I can just say that we plan to do it very, very soon. And, you know, because of the nature of how software engineering works, it's sometimes hard to give an exact date, especially in my position. I can just say that all smart contracts are ready, are in the final stage of the review. And the UI has a major upgrade, and we actually are doing closed beta testing. And as far as I know from our internal beta testing, people are just happy to see how everything looks. UI works faster, loads faster. There is more information, and the user experience is improved a lot.
Awesome. Yeah, no, good luck with that branding. That sounds super promising. Now, moving on, there's a question from Sam, and the question is related to the cron jobs and manual input. So it's more related to, you know, why keepers are even needed. Like, what are folks doing today? Like, can you tell us a little bit about using Chainlink Keepers as opposed to other existing solutions like cron jobs or just manual inputs?
Right. Yeah, I think a lot of the ways things are managed today are you have some straightforward, I need to take action at a particular time. And so you can just set that up on a centralized server somewhere and just have that run on a regular basis. You could also just have a DevOps team paying attention to that and monitor that the jobs are running as expected. But I would say there's two main concerns with that, perhaps more. First would be that you have the risk of having your software go down. There are a number of different ways this can happen. There could be events that are, even if you're on the cloud, there could be events that actually end up resulting in your cron job not working correctly for some period of time. So the advantage of doing a decentralized system is that no one solution, no one organization or server is responsible for that. You can actually ensure the entire network is responsible for that. So even if like a part of the network goes down, your upkeep is going to get done based on whatever you've set up. Beyond that, there's also a cost to maintain all of this. You need a team that needs to be paying attention to this, rather than you can just outsource that to the DevOps teams that are running these keeper nodes, ones that are highly reliable and have been securing DeFi for the last few years. So having that node reputation of the node operators operating your work for you is a nice way to decouple your responsibility and making sure it gets done correctly. And that kind of helps with moving away from, say, something like a cron job. Cron jobs are also very limited. If your use case just requires something to get at a certain time, sure, that might be simple enough, but you might have, maybe you're using that because there isn't a better solution. Maybe you need to have something that is time-based and you'd like to have some other state validated before you take action. Doing that then requires that you create maybe some JavaScript or some other, you code something and you deploy it in some solution somewhere, and then that automatically takes some actions once in a while. That means you need to take care of funding that account to make sure that it's actually properly funded and maintaining the fact that it's going to execute on time. There's just a lot of nuances that need to be taken into account when you're creating this type of infrastructure. And sophistication of your automation solution makes it more expensive, more difficult to keep reliable. So as we create more and more complex hybrid smart contracts, it's just more effective to outsource this to a system that is focused purely on making sure your work is getting done reliably. I hope that answers the question.
Makes sense, Anush. No, I think it does. And then one additional part I think I wanted to kind of focus on and would be curious to learn from this panel is about decentralization. Like we spoke about kind of cron jobs or scripts being centralized. And Roman, what would you think about that aspect of automation and why decentralized automation is important and critical in that manner?
Well, specifically our use case or maybe DeFi use case in general, like a lot of borrowing platforms, they are outsourcing the liquidation, the script for liquidation, the position to everybody, and people are running scripts and making profits. But actually those profits can be brought back, to the protocol itself, to the protocol holders, or to the treasury, or just to the treasury, so that in case of market crash, the protocols has more money just to cover the losses. So I'm thinking that those protocols are paying for running those jobs. So those money actually can be brought back to the protocol itself.
Yep, and there's also risk involved in that, right? If you just have a scenario occur where it's not necessarily cost effective for an external party to take those actions, then you're kind of left on the lurch and have to deal with it yourself.
That's why we need Chainlink decentralization, so that we make sure that this job is done, and with a guarantee, let's say.
Right, which is the hard thing to provide. Like, we want to be as decentralized as possible over time. We also want to make sure that the network itself is healthy and providing a high degree of reliability for all of our users. So over time, it's important to, as our networks continue to grow, that we have some way of making sure that the entire public can vet that these node operators are operating correctly. There needs to be ways in which we can, if a node operator is not behaving well, there has to be a way to make sure that they're not part of the system. And as we move in that direction, there's going to be more and more complex systems that can be put into place to help minimize the need for humans being involved in these interactions. And I think we're I would say at the starting point of this. There's a long roadmap ahead of us, and I think we have lots of opportunities to make more improvements.
Makes sense. Makes sense. All right, folks. Moving on. Yeah, so the next question kind of goes to the heart of development, right? So probably, Roman, I'm going to ping you again on this one, as you're day in and day out, spending time on writing code. From your perspective, how much is this important? What were you doing from a DevOps perspective in the past before using Keepers? And can you tell us a little bit about that? And then how Keepers have helped, and where do you see the main benefit for a developer? Maybe potentially small teams of developers who really want to do a lot. How can they kind of leverage that power of Keepers?
Yeah, so before that, for example, I can give you a concrete example. For example, we deployed on BSC, and we didn't expect much. The market was good, and we had a big TVL on the BSC chain. And then at one point, the market crashed. And there were not enough people running the liquidations, so that there were a lot of opportunity for that. And at bZx, we are not really running any jobs. Like when we deploy on a new chain, we run the script just to make sure that bZx protocol is healthy. But we expect third party to come in and support this, of course, for a profit.
I can also add on to that because before joining the bZx team as a developer, I did actually run a liquidation script and was helping with upkeep of the protocol. So it is very helpful to have, or so before we Chainlink Keepers was introduced, there was always competition. Let's just say the economic value of liquidating the position or doing any sort of upkeep there was always a competition on gas end. So at some points, gas would go to basically whatever the profit itself was, whatever the revenue is. And it was very inefficient. There was a lot of outbidding each other. And this was before flash bots even were introduced. So there was no private placement on transactions or anything like that. And the introduction of keepers has resulted in a reliable upkeep and backup to the whole system. So it's not just people trying to outcompete each other for execution of the upkeep. And let's say you didn't get your upkeep executed. Well, you just wasted gas. I mean, in some cases if you're bidding 1,000 GUE and you're using, and it runs through half the checks and suddenly fails because the loan itself doesn't exist anymore because it already got liquidated, you just wasted 200,000 gas at 1,000 GUE. And that has a cost. So Keepers has resulted in a better system overall for the protocol and for basically just the protocol, consistent upkeep, liquidating positions that aren't even profitable to liquidate. And it's just overall much better than the previous system of just a free-for-all permissionless system.
Yep, excellent point, Drypto. And I think if you've monitored the ecosystem for some time, you'd see that due to this exact problem that he just mentioned, a lot of people just stopped being liquidators or keepers because at some point you're just losing money. And if you have 10 people competing, only one person can win, 9 people lose every time. And that's not a great outcome. And it would require that, the profit in that one time you do succeed has to be so high that it's worth doing all the other times that you do not succeed.
Yeah, so that's actually the reason why I stopped. My infrastructure was just not there compared to some of the more professional builds of it, but for upkeeps. And you would be only targeting large loans too. So the smaller positions could accrue and were detrimental to the health of the protocol. So having this ability for Chainlink Keepers is just huge.
Awesome. Thank you for that, folks. I think that was very insightful. We are coming close to time, so I do want to remind all our viewers to please take the survey. The survey is in the link below, and which will really help us improve the content in future. I will try to sneak one more question in before we let you all go, so there's a question from Anna, and Anna says, I'm new to the smart contract developer ecosystem. Could you please tell me what really is off-chain computing and what are its benefits?
Awesome. Yeah. Okay. So we wanted to extend what the Chainlink core node was already doing for price feeds into several other opportunities for the ecosystem. And one of the clearest ones was that in order to take actions based on some set of conditions, if you were to do that on chain, it becomes extremely expensive and for the most part, just completely wasteful and not viable. So being able to take some of that logic that you need run off chain and having it run on a keeper node within the network drastically reduces that problem. It essentially gets rid of that burden. You can run most of your logic off chain without incurring a gas cost. And in doing so, you can essentially do at every single block, multiple like thousands to millions, 100,000 to millions worth of gas compute off chain just to check, is something working correctly? Do I have let's say I check 10 different addresses and 2 of them have met conditions. Instead of doing that on chain, you can have the Keeper network do that on your behalf. And once it's detected that, yep, these 2 addresses have now met the conditions, I can pass in the addresses of those 2 particular ones to the perform upkeep, which then, when broadcast to the network and confirmed, can then validate that those 2 addresses have met conditions. Rather than checking all 10 of them, you just cut your cost down by 80%. And there's various use cases in which you can do this kind of off-chain compute, where you leverage the Keeper network, and the cost essentially becomes what it would be to just have like cloud infrastructure rather than the gas cost you pay anytime you take actions on a blockchain. So given the flexibility of how check upkeep and perform upkeep work, you can do all of that within your Solidity code, which maybe you have an auditor validate it. You have internal audits, external audits, and you're guaranteed that your exact code is run on. And getting that as a benefit of using the Chainlink Keeper network drastically reduces your cost and allows you to just have a lot of flexibility in how you interact with your smart contracts.
Got it. Cool. Thanks for that, Anush. I'm sure we can talk for hours on this topic. That is such an exciting and evolving space. Folks, this is a wrap. We want to respect and appreciate everybody's time. Thank you so much for joining us today. We hope you enjoyed this session as much as we did. We'll see you next time. And if you have any more questions, feel free to reach out to us via the Chainlink and bZx Discord links that we shared earlier. Hope you have a wonderful rest of the week. Thank you for joining.